I'm happy to present Dr. Thomas Noll. He's visiting us. He is an author on mathematical music theory, the editor of the Journal of Mathematics and Music, which is going around there when we have our advances. And he's going to present the talk on central words, standard words, and their application to music theory.
Thank you very much, Mariana. Thank you very much for inviting me and especially for sharing interest in the work I'm doing. Not alone, I'm doing it with collaborators, David Clampett, Ohio State University, Carsten Young from Barcelona, and also a doctoral student, Manuel Dominguez from Madrid. Maybe in the future, some of you share this work. Let's start. These are two references, an article from Music Theory Online, this year, co-authored with David Clampett, and an article in the Journal of Mathematics and Music, which you have here. Let's start with some music. I chose the beginning of the fugue, C major fugue of the first book of the Weltrumpet Klavier.
Yeah, it's up to you.
So I'll show you once more the score. Bach wrote this cycle to show his maturity when he applied for a position in Leipzig as Thomas Cantor. And the very first fugue is a kind of pointer to backwards to the music tradition. The tones which are used in this fugue theme are the tones from C up to A. So they form the so-called hexachord. And he refers to a tradition of using this melody or these notes in musical pieces. But there is a tradition to this hexachord which has another role in music history. And this is the Guido's hexachord as a solmization technique. So a mnemotechnique, musicians, singers would name the notes they sing with these syllables. And this is interesting, that dates back. Guido lived at the turn of the millennium, and over the centuries that became a practice which we can trace well back into the 17th century. But nevertheless, the tonal repertoire was based on 7 notes, not on the hexachord. Therefore, it is interesting why musical practice used this hexachord as a mnemotechnique. And mathematics cannot give a historical answer, but it can try to look at the structures and show how do these 6 notes relate to the 7 notes of the scale. So let me give you a mathematical theorem first, which deals with a class of words which are called central words, and they appear as limiting cases of the following theorem. It's called a theorem by Fine and Wilves. You study words over an alphabet, 2 letters, 3 letters, whatever you like, and you look at some word of some length, and you say that the period is a pattern, it is a prefix of some length, p, which repeats over and over. And even if there is a certain reminder at the end, those letters must fit the pattern. So a word is called periodic with this period if it has the structure of being a power of some prefix u and some r, which again is a prefix of u.
Is r less? Does r have less?
Letters, yeah. Then
no,
u.
the length less than the length of u?
Yes. Yeah.
It doesn't say. But okay.
Maybe it doesn't say.
No, just verify. Okay, so that's.
No, it says R is a prefix of u.
Oh, that's what it means?
And, yeah.
Ah.
And then it implies.
Oh, okay. So it's just.
Please ask questions like that. So it's better to keep track of everything. So, and if you have two, now the theorem states, if you have a word and you have two periods, P and Q, such that the length of the word is more than the sum of the two lengths of the periods minus their common divider, then even there's some pattern of periodicity greatest common divider of the periods. Okay, and then they are not independent, and they are just redundant. So, but there is a limiting case, and where you still have two periods. And these are the central words, and you can construct them in the following way. This is called right iterated palindromic extension. You start with some letter, so this is our directive word by which we want to construct the central word. So we would take this first A and say, okay, this is a palindrome. You take the next letter and say, okay, this is a palindrome. Now we have B, and this is not a palindrome. So what you do now is to extend this word to the shortest palindrome possible. That is, you in that case you would append another AA. Formally, you would look for the longest rightmost palindrome, and then there is some prefix to it, and that you would reverse and append at the end. So there's another A over. So again, we would say this is not palindrome, but the longest palindrome at the end is AAA. So what we would have to do is append the reversal of AAB. And this is the result. And this is doubly periodic. You can start over here again. This is the period. What is the other one? This is the other one. No. You go until here now. The whole long prefix is the other period. So the whole world of central words is a binary tree, because the directive word had two letters. So at every node of that tree, you have a central word, and then you would either append A or B and create a palindrome. Okay. On the leftmost arc of this tree, you have just powers of A. But here we got something we have seen before, AAB, AA. I will show you in a minute again. And here are the two nodes which come later. So, everything clear so far? The other way to construct these central words is by means of their double periodicity. We have seen that we have two periods, so one is AABA, the other is AAB. And if we prepend these two periods to the word itself, we get the same result as with those palindromic extensions. So we see the double nature of these words. They are palindromes in this iterative way, and they are doubly periodic. So here's Guido's hexachord, which is an instance of that. Now you might say, okay, AABA, this is rather short, and is now this mathematical model which we superimpose on this historical musical object, is this adequate or not? So what we have to do is to interpret all these ingredients, what we find. Especially we can look at the two periods, and we see there are the fifth and the fourth respectively. So these are really very important intervals for the constitution of musical tone relations. And let me give you